just gives you a quick sense. We've also done some native app development as well. Well, overarching goals for today that I put together, what Raphael has asked me is to demonstrate free and open source geospatial applications that we've developed that are in use, that are being used broadly across different industries. And I'm going to showcase some subscription as well as custom applications that we've developed. I also thought it would be good to just introduce what urban forestry is to those who are not as familiar with it. And then what I've done is I've broken things out into tools that we've built that are specifically individual tree data management, so streets and parks or private property, as well as different tree planting initiatives and programs that are taking place that we've worked with. And then, as I said, I'll come up a level and look at more canopy or landscape scale applications for planning, visualizing, and prioritizing urban forests. So those are kind of the overarching goals. As far as the agenda, I'm going to introduce our brief history and sort of evolution of the technology stack that we're using at Planet Geo. And then I'll dive into municipal, state, private, and non-governmental organizations or not-for-profit examples of our tree inventory software. Trees, Healthy People. Another one with a nonprofit in Indianapolis that we've been working with. And then what I have are some hybrid, meaning a combination of both in one web browser map application, tree inventory, so individual tree management, as well as landscape scale applications. So we've blended those into hybrid applications. And then I have just a couple examples that are more custom applications. Finally, at the end, I'll list all of the different tools that I showed, so anybody can go and explore these tools online as kind of just a quick recap. So in terms of the evolution here, we're a small firm. There's less than 10 of us. Like I said, we've been in business a little more than 4 years. Our flagship products that I mentioned are Tree Plotter and Canopy Planner. Again, these are more or less true products as subscription software, but we do a lot of other blending with hybrid applications. But generally speaking, most of them are focused on tracking, managing, and planning information about the urban forest, whether that's individual trees and maintenance and such, or bigger picture, looking at the entire urban tree canopy. So where we started a few years ago was what we call version 1, and we're now in version 2. The version 1 was hosted with the Esri ArcGIS online solution, and it worked well for many things. We still use it here and there for specific projects or needs that clients have. We did get a lot of interest in the product pretty quickly, and we wanted to continue that momentum, but we really wanted to have, I guess, complete control over what technologies we used, our access to the server, things of that nature. So we saw that there were some limitations in terms of really being able to build a complete enterprise solution, as well as the speed and performance of the application. And then also we wanted a complete, a suite of tools for geoprocessing for any types of analytics that we might come across for different requirements from our clients. So we did a lot of different searching, researching, looking into different technologies. We knew we also wanted to have direct access to the server. We really didn't want to be locked into a particular vendor, for example, whether that's ESRI or other solutions we looked into, such as CartoDB, Mapbox, and so forth. And of course, as a small firm, we were at the time especially balancing the larger upfront costs and expenses. So we were looking at this thinking, well, we need to build something relatively quickly and reliably. We can't be building this in the sand. And we want to have choice really in how we grow as a company. So with all of that said, our decision to move forward with an open source stack for web and mobile GIS application development was really driven by the cost to entry. Really what you just need is one or more skilled developers to use these tools that already exist. We looked for the availability of mature, dependable, friendly tools we can develop that are rich with lots of features and also come with pretty good documentation. And of course, like many of you, we look at what others are doing and a lot of interesting things that folks have been doing very successfully for many years with free and open source geospatial technologies. So with all of that said, this is the long list of the stack that we're using right now in terms of technologies. A Linux environment, Postgres and PostGIS for storage, as well as manipulation of tiles and features. We use GDAL and OGR libraries for things like importing and exporting data. We have an upload tool that helps us to bring existing data into our applications. Projections that need to take place, things of that nature. We have PHP and a lot of JavaScript used throughout the applications and the code base. We chose open layers with the JavaScript library. Most of everything I'm going to show you is browser-based applications. We have a couple of tools that are that use GeoServer specifically, and we're going to be using that more later this year. So I'll talk briefly about that. We have Apache as the web server, and then I'm going to briefly, when I get into the Canopy and landscape scale tools, I'll talk about how we use QGIS, Saga, and R for more of the desktop GIS analysis, which then we put those data layers into the web application. One thing I thought I'd do for this audience that might be useful is just to very quickly, high level, just sort of list out a sample of some of the spatial functions that we use within PostGIS and OpenLayers specifically. So many of you are probably familiar with this. It really is, there are tremendous resources and documentation online. So I just wanted to give a quick example of what some of this looks like and how we use this ourselves. The last slide I have here for kind of the introduction on technology and the overview and the requirements is one we share with all of our clients, many of which are very not technical oriented. We're working with arborists, foresters, who some are very technical, but there are plenty out there. Maybe they run a nonprofit or something along those lines. And that really was one of our overarching goals that I probably didn't mention, is really enabling users to do GIS without knowing they're doing GIS. That's been a goal of mine for many years now. So what we have are largely subscription-based software. We have done some custom applications where we've done deployments locally on a server at another site. We have web-based, browser-based, and cloud-based applications. We are working on an offline module right now, but right now, all the tools I'll show you do require a web connection. So you simply go to the URL. There's no software installation, as many of you are familiar with these technologies. It's a hosted solution. You do not need secondary GIS or GPS to use, whether that's hardware or software, to use these tools. And everything in terms of data editing that we've set up that I'll show you is real-time in the cloud. We also have a version for, I shouldn't say a version, we have some manipulation to the code to allow the browser-based application to be customized and optimized for different sizes of devices. So we have the code looks at the dimensions of the device that the application comes in and is read is loaded and launched by. And so we have some of that for phones versus tablets versus desktop. We also turn off certain analysis or administrative tools on phones and tablets that you need to be at your desktop. So there's a lot of great things we can do in that regard. And lastly is the tools are map-based. That shouldn't be a big surprise. Well, as a quick transition, let me just, for those of you who are not familiar with urban forestry, I've been doing this for a little more than 10 years now, almost exclusively, in terms of anything data and technical management planning related to urban forestry in primarily the United States and Canada. I love this definition. I will read it. The art, science, practice, and technology of managing trees, forests, and natural systems in and around cities, suburbs, and towns for the health and well-being of all people. I think that sums it up pretty well. Trees in urban areas are often sort of an afterthought. We don't we don't necessarily all realize the wealth of benefits they provide. What I thought I would do as an introduction on the right here, the top right, is just to list out at an individual tree level what is urban forestry, what's taking place. It's the planting, pruning, healthcare, removals, inventorying what you have so you can better manage the resource. There are design specifications, lots of standards that are out there. So there's an entire industry within arboriculture and urban forestry at the individual tree maintenance and management level. Now, at the bottom left here, in much more of a bigger picture that impacts the entire landscape, we have policies, regulations, ordinances. There are management plans for park trees, street trees, a strategic urban forest management plan that would encompass a lot of partners, things of that nature. There are components, entire organizations that are focused on education and outreach of urban forestry. Also, in the United States here, a lot of science and research going on within the realm of ecosystem services that urban forests provide. And then I'll talk a little bit more about the assessment that we do, monitoring, and then of course, protection of the resource. So I just wanted to kind of big picture, give an introduction to what is urban forestry. I am not going to read this entire list. This is just kind of set the stage for, well, why do we manage this resource? Why do we want to expand tree cover in urban areas? There's a myriad of research studies for 30 plus years that's now really been documented and brought into practice through various tools that focus on environmental, economic, and social benefits, or triple bottom line benefits that urban forests provide. And as kind of another segue to that, this is a graphic we put together a few years ago in a report that just looked at the existing initiatives, greening initiatives in an urban area that were clients in Jackson, Mississippi had on their website. And we looked at this and said, well, trees individually or the urban forest as a whole does provide tangible benefits, whether it's water resource management, energy conservation and energy usage, air pollution, as well as directly impacting property values, things of that nature. So again, that's just a very quick introduction into what is urban forestry broadly. So what I'm going to do now is focus on the tree inventory information. So this is individual tree identification, measurement, condition assessment, and evaluation of what the management needs are of that individual tree. There have been many software for, say, 15 years or more focused on tree management in urban areas, parks, street trees, primarily other public properties. Really what we've put together, which is this browser-based application, fully based, this is version 2 that I mentioned, is designed to give exceptionally better access to information than foresters, city foresters, and related partners in that process have ever had to this information. So I start off with access to me because based on the way we've designed and developed this and deployed it, you simply go to a website. You can do that almost anywhere these days and on any device. So the access is really a huge benefit. But aside from that, it's not just a data collection tool. You can collect data, you can track and update and edit information. You can do a lot of different really, I think, innovative data management techniques in terms of, say, using spatial functions like grab this group of trees, draw a polygon around that. Now that I have those trees, maybe something updated with every one of those. We visited that tree or the management need changed or an event happened and we had to remove all those trees. So those are easy spatial functions to do and then manage data in bulk, which again is a huge leap forward in terms of just the efficacy of urban foresters and city foresters in terms of managing their data. You can also search, filter, and query. There's a series of reports that I'll show you, and then, of course, various ways to analyze the data and really present and communicate that. So with that said, let me just go ahead and jump right into the actual application itself. This is a pretty high-level overview, and I'll talk hopefully a little bit about different open source tools and where they come into play throughout the application. So we have a tools menu. I'll show you more about that in a minute. We have the editing tools under plot. So that's where we plot trees. We can add, we can open up this data table and use the data table to manage information, export information, say to a spreadsheet locally. We also have a lot of statistics in our stats tool, and I'll show you some interactive examples of that. We came up with a pretty innovative legend, so it really accomplishes several things. You can choose what layer you want to look at. So we have some applications where it's just the trees, whether that's street trees or park trees or both. And then we have other applications where we might be looking at amenities, say, or assets in parks or other properties. So you can change what data layer you're looking at. And then the display by, I'll show you in a minute, you can change what field, what data field you want to color code your information, whether they're trees or other features. So this really is a very dynamic and flexible platform that, as I tell people most of the time, it's a focused, simple, easy to use online GIS. We just happen to focus mostly on trees and tree management. So there's a whole login and administrative portal. I'm not going to really cover that today. We can see pop-ups here with different tabs, drop-down values, lookup tables with pop-up lists for, say, tree species, whatever the case might be. There's also initial information about each tree as you click on that feature that the public is allowed to see. And again, back to one of my overarching goals, we wanted to have complete control over that. So now we're able to, choose exactly which components of the application users can see based on their login level. This is a long list of the tools in the toolbox. We broke this out by the basics, sort of account management. You can take a tour of the tools. What this is showing here on the right are the different base maps we can choose from that I'm sure most of you are familiar with. Searching by address, drawing graphics, and doing measurements. Most of this, in fact, comes directly from OpenLayers API. So some of this is more custom built in terms of the My Data tab for exporting data. We can also open up a lookup table. Say we have a list of parks or a list of tree species and we want to change that. The logged in user can do those types of things. Most of you are going to be very familiar with this in terms of aerial photo interpretation and just simple digitizing. We bring this up with users so that they realize that they're not using the GPS on their device to actually collect the feature. We'll do that with the offline tool potentially, but right now, it's just as simple as zooming in, clicking on the feature, the tree, or whatever the item is. And this just shows a few of those interfaces. So I'm going to start with some more specific examples, again, with a municipal example in Tupelo, Mississippi. We finished a Canopy study, GIS and remote sensing Canopy analysis, and then as another task of the project, they wanted to get into individual tree management. So they have about 1,000 public trees in the tool right now. And again, you can go online and review and check out this tool. So again, you can see the expanded tools over here. We can click around. We're looking at the trees based on species. And let me click down to the next slide. So now we're looking at the management tab. We have different drop-down lists and so forth that we set up and administer within Postgres environment. And here what I've done is I've changed what we are displaying the trees by. So before it was species, and now we want to look at which trees need pruning versus which trees need removal, which at the very foundational level of urban forest management, those are things you're going to want to know. So it allows the users to do things that we've been doing in GIS for a long time, but in a much, much simpler way. A couple other looks here at the Tupelo example. So we can see a little pop-up. Let me see if over here, in terms of adding a tree with the tools, attaching photos, of course, on tablets or phones, or at your desk. And what this interface here on the right shows, it's one of the tools I think that's really sets things apart, and that we're really happy with the user experience and the functionality, is the ability to search and filter the data by the attributes. So these are set up to be AND statements. So show me this species and the size, the diameter at breast height, DBH. You know, if you want to see where are the largest trees of a particular species, it's just a couple clicks of the button, and you can do that. The other thing you can do is filter by the map. So using some of those PostGIS functions, we can simply draw a polygon on the map, hit go, and then now our charts, our graphs, our reporting, our data exports, they all reflect that data. So you could say, I want to go to this HOA, neighborhood, subdivision, or city, and I want to pull out a specific, you know, spatially in the map, I want to pull out specific trees in this case. You can do that very easily and then run a report. So I'll show you what some of that looks like here in just a second. So, so moving on from the Tupelo municipal example, I wanted to quickly show a statewide example. With the state of Idaho Department of Lands, we have a multi-year contract where basically new cities without tree inventory information can set up an account and use the tool to go out and start a new inventory for their data collection. But then cities who already have tree inventory data collected on parks or streets or both, they can, we built an uploader tool where they can upload their data, and it's pretty comprehensive, and it was a pretty complicated tool, and it's really still in constant development and improvement. But what we've done is the ability for essentially the aggregation of all of this information at a statewide level. So it benefits the state in terms of seeing things like maybe pests that we're worried about based on species distribution, things of that nature. What kind of maintenance issues are our cities facing? But then at the individual community level, they can compare to other cities, and they can also use the tool organically to collect their own tree inventory data. So this example is just showing how at a statewide level, or for an individual city, what we call an organization, or with a filter applied, you can create these different reports and really customize the order of the information, what information you want to include, which trees are you, is it the entire city's trees, is it just trees in a particular park, things of that nature. So that's a custom-built reporting tool that we've developed. Well, moving on, I wanted to very quickly show an example of what some communities are doing in terms of managing how they receive service requests from the public or from other city departments about tree issues, as well as then creating work orders from those service requests. So the work order is going to say either to an internal crew or to externally to, say, contractors, you know, here are 10 trees along this street. We need to prune them. We need to limb them up 8 feet for vehicle clearance, things of that nature. So that's what this tool is about. And the way we've designed it is it's really just a module. It's an add-on tool to the tree plotter software. So there's some quick buttons. That's what I basically call these. It's a way for the crews to say, I need to update the work we've just done. And it's also a way for the public to be able to come to the tool. You can just put the URL into your city's website, click on that, it'll open up just like this. I'll show you the next slide. They can say, you know, here's my name, the issue about tree. And what's really nice is they had a series of automated responses. I guess there's one other piece to mention. The spatial location is geocoded based on the address. So it goes into the application and creates a data layer that you can toggle on and off and choose between trees, service requests, and work orders. So those three are actually data layers in the application. So you can see where are they, which ones are in a particular status. So again, that drop-down choice that I mentioned earlier about layers, we have the trees as the default, but you can change that to this. So it's a quick way to see what work is needed and what's coming in, say after a storm, for example. And it also gives a series of automated email responses as well. So, you know, we visited the work, the work's been done, here, you know, here was the determination that was made. In terms of spatial functions, I just really quickly wanted to show when we create a new work order, we simply draw around the trees that we want in the map, and they automatically get dropped directly into the tool, and then you can go and set up the printing function to print the work order and give it to your crews to do the work. And then you can come back and update the data. There's some tools to what we call mass update. It shows you in a view which trees have had what work done, and then you can come back and say that all 10 of these trees or 20 of these trees have had this particular type of work done. So there's some good automated ways to really force good data integrity. And this last example just shows what one of the work orders looks like. We also track the changes in status to the work order. So you can see who logged in, who did the work, how things have changed. And again, this isn't specific to trees for the most part. This could be, it's really just a simplified online GIS focused for these particular workflows. So you can see the type of work that's needed. You have actually choice over these header fields, which fields you want in the header information versus here. And then you also get automatically a map of the specific tree in that work order. So this one only had 2 trees. They're highlighted down here in the map, and the other ones are grayed out. So there's some pretty neat things that we're doing in that regard. Okay, moving on to a private tree care firm. I just have one slide on this, just to talk briefly about what's different when we're working with private firms. The first thing is that they typically have multiple project sites. So they're not gonna, as opposed to a city that has one data set, one tree inventory, for their public trees, we've set this up at a different hierarchy where they can create a client's location or a project site. They can click on that, and then what we call, they can load the trees for that project. And it's actually how that statewide Idaho tool works, as well as a couple others I'm going to show next. Private firms also have slightly different data fields. This is what we manage in Postgres, of course. They were working towards more of an advanced login portal for their clients, so that their clients can come and see their data as well. We have certain applications for golf courses, HOAs, which is homeowner association, if you're not familiar, sometimes called neighborhood associations, and then also campuses. So there's a lot of different types of private entities that manage trees and that use this type of tool. I have a couple examples quickly of not-for-profit or non-governmental organizations. This is just a quick view of the data and the setup for Baton Rouge Green in Louisiana. They do a lot of projects with the Department of Transportation, so they can, as a nonprofit, they can plant trees and care for those trees with an agreement with the Department of Transportation along these right-of-way or transportation corridors. So that's kind of unique. We also have the ability to use some of the science and research in urban forestry to place benefits in terms of stormwater mitigation, property values, energy reductions, air quality improvement, and carbon sequestration and carbon storage that the trees either now or over time will provide. Just the last example showing this little window to take a tour of the application. So in this case, there's 11 slides to come through and see how to use each tool, each sort of primary tool. And then this is a view of some of the reporting. So you can choose pie charts, bar charts, table view. You can do things like stacked bar charts. You can save those, as well as print that directly to an actual report if you want. So these are stats that are basically done for you in the tool. The second nonprofit example was recently just launched in Missouri, and they have an initiative to plant 1 million trees and to track this. And so we've been working with Forest Relief of Missouri and the Missouri Department of Conservation and the Missouri Community Forestry Council on this tool. And really for them, it's largely a tracking tool, but it's also public relations and communications. So we were able to just, with some fairly modest changes to the tree plotter platform and the code base, we were able to set this up at a statewide level with a hierarchy of multiple organizations creating accounts, and they can track things like what species are we planting, how many trees per year, things of that nature, as well as what are the the future benefits of those trees. From a GIS perspective, we have two different layers, if you will. One is the project location. This is similar to the private tree firm example. And we have the individual trees. So this is just a quick example to show how the user in the little drop down here can click on a project, see the number of trees that were planted, who was involved, who was the organization, and when did it take place. And then they can zoom directly into those trees and quickly see some information about that, what was done for that project. The last example that I have for the tree plotter side of things, meaning the individual point data type of web application, is just outside of, just near us in Denver. It's a mixed use property, not very big, where we went on the ground and did the tree inventory with one of our arborists. And what they really wanted was an online community GIS. They actually started off with a request for proposal that was asking for an ESRI solution, I think specifically ArcGIS Online, if I recall. And after some questions and answers, they came back and said, you know, we are comfortable, we're open to having an open source solution. And that's, to a degree, that's why I wanted to highlight this example today. And so we inventoried a little over 400 trees on the property, as well as about 75 community assets. So these were, you can see them in this list here. It's a little tough to see. Benches and playground information, light poles, garden plots, trash cans, benches, things of that nature. So in the same way we can do online data management with the tree information, we can do the same thing with other features, assets, or amenities. And really, it's a tool for them to be able to communicate with residents and contractors. And it comes down to them tracking the maintenance that they do and being able to, again, communicate that with others. So their welcome page has these 6 different buttons. And what I'll show you on the next slide is something kind of interesting. It's a little bit different than looking at the tree information, but now looking at point, line, and polygon data, you know, the tenets of GIS, we have these quick views where just simply clicking one of those quick buttons from the welcome page loads the application to show you an overview in terms of ownership, so property ownership, topography. They wanted to add fences because there's, you know, ongoing maintenance related to fences. And that way users can click on a fence and see the last time that it was maintained or in some way. And we have impervious surface, of course. The state was provided actually by the city and county of Denver, but the HOA wanted to have it in their application. So you can click on these and just track different types of maintenance that takes place over time. And that's really the take-home message from this is the flexibility of the platform to provide the solution that was needed, and also just the maintenance piece and communications for them specifically. So at my halfway point here, I'm going to see how I'm doing on time. Okay, hopefully a little more than halfway actually. I want to switch scales and talk about at the landscape scale, looking at the entire tree canopy. The type of work that we've been doing with open source software, both, I'll start off at the desktop level and then focus mostly on web and mobile. One of the things that I've been focusing on for about 10 years now are remote sensing land cover classification projects. I've used a lot of Esri tools for that, as well as Feature Analyst, which is an extension. There's several other tools that are out there that are similar. What you do is segment the landscape using typically multispectral imagery and LiDAR, if you can get it, and doing very high resolution analysis. In this case, on not just tree cover, but also where could we expand or plant in the environment. So where do we have areas that are low hanging fruit for expanding urban tree canopy? Where are priority areas to do that? How much tree cover do we have in certain geographic scales? So maybe citywide versus by watershed boundaries, or let's say political districts, or more at the neighborhood level or even block level. So we we've been doing this from, again, a desktop geospatial analysis standpoint for probably well before I started Planet Geo, in roughly 75 or more cities and counties in the United States and Canada. So I just wanted to kind of set the stage on the fact that we have a blend of certain technologies, other proprietary software, and then we use Saga, QGIS, R, and Python for a lot of the behind-the-scenes calculations. And I'm just going to, very high level, introduce kind of the workflow of what this looks like. So we have the image analysis, if you will, here more at the top, and over this direction, where we use Python and Saga, where we do the object-based image analysis, which is the remote sensing with Feature Analyst. We have Python scripts as well as R and QGIS components to basically do a quality control of the data to increase the accuracy to what we need. We have the final land cover, and then we use some R scripts as well as raw Python to basically summarize how much canopy, based on the raster data we have for these different target geographies. So what I'm going to show you in the web-based tool is really this piece. And I have a little bit of examples on the actual raster data as well. But largely, what we want to do was make it easy for users to see where do we have a lot of tree cover or not a lot of planting potential, or really high impervious surface area. So those are three of the biggest metrics, I guess, from those studies. The first example is what's called the Trees and Health app. You can go online and see this and watch the tutorial video. We worked with Portland State University with funding from the U.S. Forest Service. And there were 13 cities in the tool. And really what it was focused on is the ability to, what they have is APP, the app, is assess, prioritize, and plan. And this is essentially an early version of our own what we call Canopy Planner software. So what I'll show you next is going to look a little bit similar, but the gist of it here is that you can prioritize areas. In fact, let me start over. You can filter the data with the slider bars to show areas that meet specific quantitative measurements. So the data that was provided to us by the university relates to air quality, urban heat islands, vulnerable populations in terms of health, and then also impoverished areas. So it's a pretty quick way to say, I want to see areas that have certain conditions, I guess, environmentally, but also socioeconomically. You'll see some similar, excuse me here, you'll see some similar examples in the next couple of tools. I want to go kind of quickly because I don't want to miss out on questions and answers. This is our Canopy Planner software, which is using the same stack of tools that the Tree Plotter tool is on. The only difference in a couple of the applications is we're using GeoServer. But otherwise, we can have the landscape scale tool within the same application as our individual tree tool. So I'll go through this very quickly here. We can choose what geographic scale we want to look at: neighborhoods, parks, block groups, things of that nature. It just depends on what data was given to us. These maps represent the amount of tree cover there is, but you can also look at how much potential tree cover there is in terms of not looking at agricultural areas, for example, but looking at areas where it's turf grass, things of that nature, where really it's the low-hanging fruit for where we could expand urban tree canopy. So we've come up with three tools: View, Plan, and Grow. And I will just very quickly again show you what those look like. So View is simple, just show me areas with a certain percentage of tree cover or planting potential. When you come to the Plan tab, we have these different criteria or themes. I think, do I have an example? Oops, sorry. So you can hover over these. It's also a good educational tool, but we're looking at things like higher impervious area percentages, predominance of, let's say, certain water quality or water bodies, where expanding tree cover for riparian buffers would have the greatest impact. So what this tool allows you to do is really a site suitability, and you can weight with the slider bars certain things as a high priority or not a high priority, and you can see how the map changes pretty much instantly. So you can see this area I've hovered on is the 5th out of over 600 areas in terms of its ability to meet all of these criteria for the urban forestry goals that we have. This next example is just showing what we call our grow tool. And what this allows you to do is say, well, what if we increased the canopy in certain areas? So we've selected these areas and we've told it how much canopy do we want to add. And what we see on the next slide is a report that shows us essentially our grow out model. So here's what you have, here's what you modeled, and what would be the ecosystem services impact of expanding the tree cover. And then it shows you what you actually did. So we took these areas, we modeled the canopy, and here's the overall impact down below. So it's just a quick example of one of the other types of analysis tools we've built into this platform that really integrates with that initial geospatial analysis that we do at our desktop. Moving into the custom and hybrid examples to wrap things up. This Columbus, Ohio tool with a very comprehensive analysis, report, training, as well as a web tool for looking at landscape scale, as well as engaging basically organizations to be able to put tree planting events into the map to show what's an upcoming event. And if it's an upcoming tree planting event, there's a button for volunteers to sign up. So what we've done here is you can add events just like adding a tree. You can add individual trees then to that event. And again, as I mentioned here, there's a sign up button. So users can basically say, I'm with this organization. We're going to have an event in 2 months. We want to put it into the map. We want to communicate that out, get folks to come and realize the type of work we're trying to do. And then it allows them to engage folks as well as track, of course, what they're doing through these projects. So it's just a bit of a hybrid where we have both. You can see here the canopy button as well as the plot. So we've got both of those tools at different scales in one application. It also helps for future maintenance of the trees. So just because you planted the tree doesn't mean it's going to survive. There's a lot of work that is needed in terms of watering, mulching, just protecting the young trees as they're growing. So this is a good way also to say, well, let's go back and look at the trees we planted 1 or 2 years ago. What kind of maintenance do they need? I just have a couple more. These are more, I guess, less hybrid and more custom applications, still using the similar stack of technologies in terms of open layers and Postgres primarily. So this is a tool in Mississauga, Ontario, which is just outside of Toronto. Basically, in trying to stay high level, we have 10 different criteria that come from field data that's been collected in their woodlots. And so the city manages about 300 woodlots. What they wanted to do was have a tool that can help with communications as well as with management. I guess also education, because you can see, you can hover over here and say, well, what does this particular criteria mean? So again, they have 10 different criteria, sort of indicators about the health, maybe the status of that management unit or that woodlot, and they can come around and click and see the individual essentially grades. So what this tool is designed to do is to assign a score from poor, fair, good, and actually then create a grade from an A, B, C, D, F standpoint. And I'll show you what that looks like. Oh, no, I guess I just had one slide. So yeah, I just wanted to, you can go online and go explore this tool, but it was something we were able to spin off from the core code base pretty quickly, and then just develop really with CSS and so forth, some of these other panels and views. But it's another urban forestry application that's pretty unique. The last one that I want to show you is a tool we built for the U.S. Forest Service and University of Vermont. It's called the Forest Carbon Explorer. It is not, it's not a true urban forestry application, because this is data from the lower 48 states of the United States at 250 meter resolution. And what I'll just quickly walk you through is what they wanted to do and the tools. You can see the technologies we used to build this. So we're using GeoServer to display the 250 meter, in this case, gridded forest carbon information. And I'll just go to the next slide and show you a little bit more about this. So the goals of the project were to develop a very simple smartphone application to explore not only the extent, but also the value of the nation's forest carbon resource. This is information that has been provided to the United Nations, for example, in static reports and charts and graphs over the years, and that they wanted to make into more of an interactive experience in an educational tool. So what we've developed is we've taken the 250-meter data, which comes from both field inventory, what's called FIA or Forest Inventory Analysis from the U.S. Forest Service, and they blended this with a remote sensing process and provided us with essentially these 7 pools, as you see over here, these 7 types of carbon that are stored over time in forests based on the data that they have available. So what we did was developed a tool to interact with that. You can draw a radius. In fact, these methods here, you can use your GPS location very simply and determine how much carbon is in the forest around you. You can do this by county, either by clicking the county in the map or from a list of tables, or you can interactively draw a radius in the tool. So I'll just very quickly show you what this looks like. There's a wizard, so you can walk step by step through this and choose which counties that you want to see the amount of forest carbon. Like I said, you can do that in the map or in the table. And then more interactively, which was really the initial idea, is with a radius. And I'll just quickly show you a couple of these, what they look like. So here we've zoomed in, we've turned on the county layer, and we can just say drag and select on the map. So simply click those 2 counties, and then you can say get carbon. What I'll show you in the next one real quickly is the other tool, the radius tool. So here you simply on your phone or a tablet or at your desk, you can drag the center point outwards and create the radius of the area. And what this does is, this is really where the spatial calculation comes into play and why we think the application is so exciting. So you can be wherever you are. It hits the server located, it's a Red Hat Linux server in University of Minnesota, and it does the tabulation. It does the calculations based on the pixels. And it's really incredibly fast. We've shown it to a lot of people. They're very impressed at the speed. So I would definitely recommend taking a look at that. Again, like I said, this is using PostGIS, GeoServer, and the open layers, as well as some other libraries. So what you get when you say get carbon are these 3 tabs: the amount of carbon, the value, and the equivalence. So this is just a different way for users to then see and explore the information about how much carbon is stored in the forests near them. We used the U.S. Environmental Protection Agency greenhouse gas equivalencies calculator that you see mentioned down here for some of these stats, and there were a couple of different resources for the market as well as social-based valuations of carbon. So I would encourage you to explore that. Looks like I'm just shy of the 1 hour right now, so I'll just wrap up basically. What I've done here is just a long list of all the tools that I showed today. So you have the URLs. You can go explore those, send us questions. Just real briefly, we take all of the studies we do for urban forestry, whether they're assessments, inventories, management plans, and we put those on issue.com, so you can go explore the work that we do there. If you're interested in learning more about Tree Plotter, there's a big, long, ugly URL to our website. We also have a light free version we call Plotter Lite. It's a very simplified set of data fields, but it's really a starter tool for schools or say small nonprofits or just folks who are interested in collecting data. So it's just a very light, simple version of Tree Plotter. And then we have lots of recordings from our own webinars that we do that are on our website as well. I will stop there. There's my contact info. I just real quickly wanted to say thank you once again for the opportunity, and I will take any questions that have come up.
Great, Ian. Thank you very much. Very interesting. Everyone, if you could please, if you have any question, you move your mouse pointer to the bottom of the screen of this system, you will see a chat icon. And click on the chat icon and send a brief message that you have a question, so I can turn on your microphone to put your question. So again, roll your mouse pointer to the bottom of the screen of the system, and then you will see the chat. A menu pops up, and you will see a chat. Click on chat and say a question, and I will turn on your microphone for any question you might have. In the meantime, while this happens, Ian, let me take this opportunity and time to ask you something. You know, these systems seem very sophisticated and useful, and they are based predominantly or entirely in open source software. In your experience in developing the systems, did you find something that you were wishing, like you have seen in proprietary software, and say, oops, you know, proprietary software has better documentation, or maybe they have better functionality, or is easier to do development? Did you find that experience, or was it harder in open source? Can you quickly comment about that?
Right. I had a little trouble hearing the very last part that you said, but I mean, the first thing I would say is the benefits we've seen far outweigh the negatives. So there is, by and large, there's sufficient documentation of what we're doing that has worked for us. You know, it is very feature rich, and in some ways, we're not even using probably a lot of the different spatial functionality that's available out there. You know, we've been building on this stack for only about 1.5 years. That's not that long. So, and like you said, everything that's in these applications on screen here is 100% open source.
Excellent. So again, everyone, if you can roll your pointer to the bottom of this system and then chat and then send us a message, or I will try this, see if it works. I will unmute all the microphones, and then you could ask directly the questions. We'll see if it works. So now you should be able to unmute your microphone. Again, roll down the pointer towards the bottom of the screen of the system, and on the lower left you will see the microphone icon, and you can unmute it. So if you can try it, that will be good. Right now, still everybody's muted. If you have any questions. Okay, in the meantime, so if you didn't feel in particular that you were limited by the capabilities of open source software in some way, shape, or form. Yeah. Hello. Okay, questions from this is from Humphreys. It's a question from a developer's perspective. Leveraging a FOSS stack requires perpetual updating, isn't it?
I realized I was on mute, and I didn't realize that. So sorry about that. So I was trying to open the chat window so I could see these coming in.
Yeah. Again, roll down the pointer of your mouse to the bottom of the system, and the menu pops up, and then you see the icon chat.
Let me, yeah, not seeing that for some reason.
If you roll down again,
there, I can see the chat window now.
Okay, good. So
okay.
Now we have a question from Humphreys.
So the answer is Esri requires constant learning also.
Yeah, I guess one of the comments would be that, you know, there is constant learning with an open source environment, but at the same time, any other proprietary tool, Esri or lots of others, are going to require a similar amount of ongoing training, you know, and education and learning. So, let me know if that answered the question.
Again, Humphreys, if you want, you can short it. He says.
Okay, great.
Okay, good. Are there any other questions? Again, you should be able now to turn on your microphone. Again, roll down the pointer to the bottom of the system, and then the lower left you will see the microphone icon, and should be right now with a red cross. but you can click it and it will turn it on. So I guess just developing on Humphrey's question, there is no difference. You still have to, whether it's proprietary, private software, or open, you always have to keep an eye on updating and working on it, right?
Yeah, that is correct. Yep.
Now, there has been some comments in developing systems like the one you show us, that when using some proprietary solutions, people argue that they are more integrated, that they flow easier, or they are a more integrated stack. And in comparison, FOSS4G stacks tend to be more loosely coupled. What has been your experience regarding that?
So let me, I guess, first restate the question and make sure that I have everything. So basically, is the statement that there is easier or better ability to integrate softwares between one another with proprietary tools than with open source tools? Is that the primary question?
Well, let me clarify a little bit. More like, for example, ESRI could have a stack of software from desktop software to web server to mobile applications that are more integrated. So there is the argument or the perception that this is simpler to do or more integrated, easier to do it. While in comparison, trying to achieve the same integration through the use of open source tools tends to be a little bit harder or complicated, because the components, the desktop to the mobile to the web server, tend to be more loosely coupled.
Right, sure. Yep. Yeah, I mean, our products, how do I want to say this? You know, let me think about this one. I would say from our experience, we've had, you know, as a browser-based platform, it's created very good accessibility. There are challenges in terms of just cross-browser compatibility and things of that nature in terms of integration. But you know, as far as Esri having, say, Arc Collector and things of that nature, I mean, we've been able to keep the application pretty light and expand and enhance and build upon it over time, while maintaining good accessibility across various devices, things of that nature. You know, and a lot of that's built into the technologies we're using to some degree, at least. So, and then of course, there's lots of libraries to choose from and things of that nature. So there may be that perception is probably not completely false, but there are definitely with good developers ways to think ahead about the technologies you're choosing and what the impacts are going to be, and how to maintain what your core tenets are in terms of accessibility and potential integration. And I guess just on that note, we've been asked a few times recently to do more, and I don't think this is exactly your question in terms of integration, but we have been asked to do more integration with, say, you know, Esri solutions or CityWorks or, you know, programs such as that. And it's something we're looking at, and it's definitely doable. We're also working on a REST service API as well this year to do more integration and consumption between applications, including our own data used in others. So there's a lot that's doable, and that I think we're going to be encountering and hopefully successful on this year.
Excellent. All right, so last chance for a question, to try to keep it within the time limit that we have established. We will, of course, post a video recording of this presentation as well as the slides on the Geo for All webinar webpage. And there in the slides, as Ian said, you have the contact information in case you have more questions or comments for Ian. You can do it later on your own time. So any last chance for questions? I don't see any. All right, Ian, we really appreciate your time and your very interesting presentation. And again, thank you everyone for attending this webinar. And please keep an eye on the coming webinars. The next one will be in about 3 weeks, and we will be posting the announcements and sending also an announcement through the mailing list. Thank you, Ian, again.
Thank you, Rafael. I really appreciate it. Take care.
Okay, I'm now finishing the meeting. Thank you, everyone. All right, so perfect. Let me turn it